at these margins of error, this helps us lead into a confidence interval. So a confidence interval is going to specify a set of plausible values for some population characteristic. Now we'll be focusing on population proportions in this chapter, but we'll also be looking at a few other population characteristics in the next few chapters. So it's an interval that we think includes the value of that population characteristic. So we can think of this as giving a range of values that we're relatively confident is going to contain our true population characteristic value. So with a confidence interval, you're going to state a confidence level, and that level provides us with the success rate of the method that we're using to construct the interval. And confidence levels are frequently 95%, so that would say that our success rate of this particular method is 95% successful. Sometimes we do 99%, sometimes 90%, but it's usually one of those three. Confidence intervals are relatively easy to calculate for proportions. You take your sample proportion, you subtract the margin of error. You take your sample proportion and you add the margin of error. Sometimes we can be a little lazy and we can put that together and say it's p hat plus or minus the margin of error. And so what those confidence intervals will do is we are confident that these intervals will contain the population parameter in C% of all possible random samples. If we were to do this method for every single possible random sample, then whatever percentage that we've done, say 95%, we will contain 95% of those intervals will contain the true population parameter. So when can we use a confidence interval? Well, first, the sample has to be a random sample. Okay, we're looking at the same conditions for that margin of error calculation. If it's not a random sample, at least it needs to be representative of the population, and the sample size needs to be large enough. So we do n times p, n times 1 minus p, they both need to be greater than or equal to 10. So as long as these conditions are met, we would form our confidence interval with p hat plus or minus the margin of error. Now earlier we were simply looking at a 95% confidence interval. Now we can do any percent confidence interval. And so we'll calculate this z critical value. This is coming from our understanding of the normal distribution. And we're looking for how many standard deviations you have to go in order to get that percentage. So we've already established that if we do negative 1.96 to 1.96, that gave us 95%. If we wanted 90%, the critical value that we would get is 1.645. If we wanted 99%, the critical value would be 2.58. Now you can do any confidence level that you want. These are just the three most common. If it was something other than these three, then you would absolutely just use technology, and you'll probably use technology for this regardless. What's important here is how we interpret. So the interpretation for the confidence interval is that we can be confident that the actual value of the population proportion is included in the calculated interval. So whenever you are concluding, you're writing your solution to any problem, then you should put this statement into context. So just give some details as to what you're trying to estimate. Now, we interpret the confidence level by giving the approximate percentage of the time that this method is expected to be successful in capturing the actual population proportion. And it's based on this theory of the normal distribution. Example 9.4 helps us set up a confidence interval. So when unemployment rises and the economy struggles, some people make the decision to move in with friends and family. So researchers studying relocation patterns were interested in learning about the proportion of adults 21 years or older who moved back home or in with friends during the previous year. Now this was done in 2008, which was the last time that we saw a big spike in unemployment, and we currently are in that same situation right now. So we could probably repeat this study and also see some changes from 2020 from 2019. So from this survey, we saw that there was a total of 743 adults in the survey, and 52 reported that they had made the change from living independently to living with family or friends. So the first thing we'll want to do is calculate our p hat, which in this case is 52 over 743, and that is approximately 0.07. Now, we need to decide what type of confidence interval we want, and typically we'll go with a confidence level of 95%. If it's not stated, 95% is kind of the standard. And so that means our z value is going to equal 1.96. So what do we need in order to do our confidence interval? We need p hat plus or minus our z critical value, and then our square root of p hat 1 minus p hat over n. So let's plug in these values. 0.07 plus or minus 1.96, and then 0.07, 1 minus 0.07 divided by our study size, which was 743. And you type that into a calculator, you're going to see that you're looking at 0.07 plus or minus 1.96 times 0.009. Then we will do our confidence interval, 0.07 minus 1.96 times 0.009, and then 0.07 plus 1.96 times 0.009. I apologize if I wasn't able to fully cut out that little jump in the video up to a higher point. I'm not sure what I touched. But anyway, going back to this problem, this is giving us the range of plausible values for the true population proportion. So we calculate this, we get 0.0524 up to 0.0876. So based on this study, we are confident that the true proportion of adults 21 years or older who move back with friends or family is between about 5% and 8.8%. So we would write that in a sentence where we would say we are whatever percent confident, which in this case is 95. That changes if you're using a different confidence level, but we are 95% confident that the true proportion of adults 21 and older who moved back home with friends or family is between these two values. So that's how we would interpret our confidence interval. We put it back into context. What is the proportion that we were trying to estimate, and how confident are we, and what are the values that we think that it could be between?